Alrighty, so let's tackle this with latitude and departure. I'm going to be using all kinds of different pens here, so bear with me. Okay, so we have the change in latitude equals, oh, that's not going to work. Change in latitude equals the cosine of the angle times the distance. Okay, and then the change in departure is the sine of the bearing times the distance. Okay, and then we have that to find the bearing. It's the inverse tangent of the departure over the latitude. Okay, that gives us the bearing. Okay, so I didn't give you any bearings on this figure. So what we're going to try to do is figure out our bearings based on our changes in departure and latitude. So I'm going to figure out the first one here, and I'm going to go counterclockwise around the figure. So I'm just going to draw these in here. Okay, so this is basically, I'm making right triangles the whole way around. That's all I'm going to do. Okay, so I have a right triangle there. I'm going to do one here too. I'm going to go ahead and do those all the way around, just for clarity's sake. Okay, by the time we're done, we'll learn a big giant square or rectangle. And this last one, and you guys don't have to do this if you don't want to, but I'm doing it so that way we can talk about this a little more clear sense. Okay. So I drew my right triangle. So I've got this area here, it's a right triangle. This is a right triangle. This one is, and this one is. Okay. All right, so we're going to end up using, because I want to figure out the bearings between these, we're going to be using this bearing of the bearing is the inverse tangent of the departure over the latitude. Okay. So my first one then, I'm going to tackle this one right here. We're going to need to figure out the change in departure and change in latitude. So what is my change in latitude here? Okay, that would be this. So the change in the northings for this particular figure. And I want to preserve the side, okay? Or the sign, not the side. So if I have 1362.79 and I subtract 2000, I am minus 637.21 feet south of this point here. Let's call this point A, and we're going to point B. Okay. I might as well label them all right away. C, D, and E. Okay, so I have my change. It's a negative 637.21. That's my change in departure, and that's all I did was take 1362.79 and I subtracted the 2000. Okay, because I'm heading in the south direction, so I know that has to be a negative. So that gave me the 637.21. What is my change in departure here then? Change. So it's 1495.80. Okay, so we think about this. All right. What direction am I heading in here? If I draw a cross, I'm heading southeast, right? So this is going to be a southeast direction. So I know that that is the negative positive direction. So if I look at my numbers here, I'm going negative in the northern or east or northern or south, north or south. I'm going to the negative, and the east direction is a positive, so we want to keep that a positive. So that's what we got going there. Okay. All right. So let's take and let's figure out our bearing first, and I'm not going to use any signs for the bearing right now. Okay. So when we figure out our bearing, we're going to take and do the, so our bearing is the inverse tangent of our departure over our latitude. So departure over latitude, 1495.80 over 637.21. So our bearing from A to B, boy, this pen is terrible. A to B is what? Does everybody understand how to do the inverse tangent? Anybody get an answer? It will be in degrees, yes. So that's what it'll yield, is degrees. I've got 66 degrees, 55 minutes, 34 seconds. So it's 66 degrees, 55 minutes, 34 seconds. All right, so we know, because this is in the positive or negative positive quadrant, so down over here, we know it's a southeast. Okay, so that's all we have to do is label it southeast, and it's 66 degrees, 55 minutes, 34 seconds. How about our distance now? The distance, we need to know the distance from A to B. Well, that's simple, Pythagorean theorem, right? So we can take, we're looking for the hypotenuse, so we will just take the first side squared, or take the root of, or square root of the first side squared plus the second side squared will give us the hypotenuse. Round up. You round up. But if you figured it out with the angles and everything, that with the calculator with angles, instead of doing the calculation longhand like you're doing, it'll come out to be 66, 55, 33.67. That 0.67 you round up to 34 degrees or minutes. All right, so we're going to take, so we're looking for the hypotenuse, and we're going to have square root of 637.21 squared plus 1495.80 squared, and that is going to equal what? Did anybody get it? Say that again. 1625.87. Everybody concurs with that number? Okay. So our distance then is 1625.87. All right, so now that we did this first one, I want to see if you guys can do B to C on your own. Okay, B to C. I'm going to putz with it, but as you get going, go ahead and give me some numbers. Hang on for a second. All right. So what do we have for a bearing and distance here? Anybody?
46 north, 46 degrees, 12 minutes, 13 seconds east.
Seconds east. Okay. How about the distance? 1820.99 feet. Anybody else concur with that? Okay. Okay, so basically, we're figuring out the right triangles here and stuff to figure out our distance across there and everything. Okay. Now, this only works if it's a closed figure, so this has to be a closed figure in order to do this. But one other thing that you guys are going to end up running into eventually, and I don't know if it's on the assignment, actually I do think it's on the assignment, I ask you to take and label the interior angles. So what's my interior angle here then? Okay, can you tell me what my interior angle is here between these two bearings? Based on those coordinates that we used. See how good you guys are. So if I flip-flop this here and make it a northwest, my crosshairs, okay, so it's a northwest bearing and this is a northeast bearing. Basically, it's this angle and this angle, right? So I'm just adding these two together to figure out my interior angle. So what would be my interior angle here then? 115 degrees. 113. 07 47. Okay, that's my interior angle. So on the assignment, when you guys are looking at that assignment, I'm asking you for interior angles as well. So you're going to give me the bearings and distances and the interior angles between each point that I have given to you. And you're going to take and draw it to scale. So so you guys get the gist of this going all the way around then, right? So we basically use Pythagorean theorem once we figure out the change in latitude and change in departure. So this is the change in latitude. This one here is the change in departure, or opposite. Do this constantly. This is change in departure, change in latitude. Okay, sorry. So anything change in northing is change in latitude. Anything change in the easting is change in departure. So we figure those out. We can do the Pythagorean theorem there. That gives us our distance. We can take the arctangent of the departure over the latitude, and that'll give us our bearing. But we have to know like what direction we're actually heading. It won't give us the north or the east, or the north or west or south or east for those. Okay. So that arms you guys to be able to tackle that assignment. Okay.